Hey guys, welcome to this new video where we are going to understand how ingestion happens on Databricks Lakeflow. Many times there is a question like how you ingest data in Lakeflow, and there are numerous methods that we derive out of the situation. Like whatever is the scenario, based on that we take the decision. I have tried to consolidate all these experiences of Lakeflow ingestion into one white paper, which I am going to narrate in this video. So if in your project, if at all you get confused, like which type of ingestion to use for Lakeflow and in what scenario, please do listen into this. So let's start. The question that we are trying to answer is when to use what type of ingestion on Databricks Lakeflow. Modern data pipelines operate in an environment where information arrives at different speeds, volume, structure, and levels of reliability. Whether your data originates from an enterprise system, IoT sensor, SaaS applications, or in a database, or any ingestion platform, your ingestion strategy determines the efficiency, cost, and reliability and scalability of your lakehouse. So whenever you are even migrating a big application, one of the big strategic decision that you have to make is what type of ingestion strategy or data ingestion strategy I have to use, whether it's one time or like how the data will be ingested throughout the life cycle of a project. So this is a very important and key decision. Databricks Lakeflow has unified ingestion through Connect. There is something called Databricks Connect and declarative pipelines and jobs, providing a single platform to bring raw data into Delta Lake, no matter the complexity of sources. This white paper explains when to use which ingestion pattern within Lakeflow ecosystem, enabling organization to design ingestion framework that are resilient, scalable, and business aligned. Data ingestion is no longer a simple ETL step. It is front door of Lakehouse, the first point of contact where quality, lineage, and trust are established. And it is very critical to set it right because in terms of cost as well, this is one of the most important factor. A modern ingestion layer must answer the questions: do we have the freshest possible data or periodic snapshot? Do we need the freshest possible data or periodic snapshot? Should ingestion be incremental, continuous, or triggered? How do we track metadata and handle malformed records? What about schema drift, late arriving data, and CDC? How do we ingest from databases, SaaS, API, cloud storage at scale? So these are the couple of questions that we need to ask whenever we are starting to take the initial assessment of ingestion. Lakeflow has given certain options, and choosing the right technique, we need to determine the characteristics of workload. So on a broader level, there are four pillars of ingestion. The first one is batch ingestion, like we have broadly categorized it. First is batch ingestion, second is incremental ingestion, third is continuous ingestion, and fourth is an enterprise ingestion. Now each pillar have their own have served to different operational scenarios. Let us understand one by one. The first one is batch ingestion. When we call a batch ingestion, when you need a simple one-time full load. So for example, you are migrating a database and you need a initial dump of that database because maybe after that you are going to get the data directly into your cloud. But first time you definitely need a dump. So that is called the batch ingestion. Batch ingestion remain relevant because many workflows still expose static, infrequently changing data. When the data is static and infrequently changing, what we use is create table as select, CTAS, we call it as CTAS, create table as select, and simple spark dotted operation. Batch ingestion offers the fastest path from raw files to delta. Batch ingestion is best. When to use the batch ingestion? When the entire dataset needs to be reloaded or backfilled. Data volume is manageable in hundreds of GBs and not petabytes. You are building or refreshing of the bronze table for the first time, so only initial load is something which batch ingestion can serve. Data updates are very rare, like maybe just a final one sort of an incremental update we might do, but overall there is minimal or no updates, and downstream consumers expect a full snapshot at a time. So this is a very typical scenario, and in that we use something called batch ingestion, and we use a technique called CTAS, create table as select. Now how these work out in terms of code, will have a separate video for that, but for now you must understand. So whenever there is a scenario where single snapshot, one time load and manageable data load is needed with infrequently changing data, you should do a batch ingestion, and for that technically you should use something called CTAS, create table as select. Moving to second scenario, when the file arrives periodically. So for example, on a daily basis the file is arriving. Okay, so file is arriving but not like minimal, it's arriving frequently. Incremental batch. So many operational systems drop new files onto cloud storage, maybe every hour, every day, based on the business events. These data sets tend to append only, and goal is to process only the new upcoming files. We need to just process the new file and not the entire data set. The scale. Earlier the scale was huge. Now this time it's incremental. The size of the data will be small. It will only be the incremental component. In such cases, uh, size is small, frequency is higher. So in such cases, we should use something called copy into and autoloaders incremental trigger. These methods are ideal when new files arrive regularly in the storage location. You want ingestion to be lightweight and cost effective. There is no need for real time. Okay, it is the frequency is definitely higher than the batch, but not that much that you need quickly, like few seconds of frequency you are required in your application, right? So for such thing you should definitely go for ingestion, which is incremental batch ingestion. The source is append only, and schema may evolve but in controlled manner. It will evolve but in controlled manner. So copy into is a simple SQL copy into, we write down, and then we just orchestrate it via maybe a Databricks jobs, and then we can directly copy the data from source to destination. Daily orders, incremental billing files, hourly application logs, IoT device data loaded in every few minutes. For such thing you can go for copy into. And most importantly, where you don't need merging, you don't need to merge the data, it's mostly append only. Okay, so this is how on the scale, let's say extremely infrequent, batch ingestion and large size, then we go for frequent but smaller size done at a particular interval, then it's a incremental batch ingestion. For that we use copy into and autoloaders incremental trigger. Third type is continuous streaming ingestion. So when you need a low latency or high throughput, like we just need the data in minutes compared to hour. Okay, maybe sometimes in seconds also. So modern analytics sometimes increasingly dependent on streaming data, because nowadays AI is there, right? So AI needs to take decision, and that decision needs to be quick. So for that, nowadays one of the most popular format of data ingestion is kind of a continuous streaming ingestion. Click streams, IoT sensors, payment, telemetry events. These workloads require ingestion framework that adapt to unpredictable arrival pattern. So earlier the first one was arrival was just once, second was frequent arrival. Now here it is like unpredictable arrival pattern. You can't, you never know when the file would arrive, but it would arrive extremely frequently. So allows pipeline. Databricks autoloader is something which we use for such scenario, and in that it has something called continuous mode combined with structured streaming. Allows pipeline to ingest billions of files with minimal operational overhead. So internally it would take care of everything. So those who have worked on such projects of ingestion, they would realize how important this component is. Otherwise you have to maintain a lot of things. Let's say similar thing you want to implement in AWS, you might have to take at least half a dozen of services, integrate them together, maintain them, and then such thing would be possible. So this is the greatest thing that I have ever seen. Like with just few properties, Databricks would take care of it. Okay, so streaming ingestion is the right choice when data must be available in real time. You must expect irregular arrivals and high throughput is required. Files may arrive out of sequence. You may want the system to detect and evolve schema automatically. You require streaming bronze, silver, and gold transformation. You may want to have this transformation done in a streaming pattern. What you use is something called autoloader, and mode is continuous mode. Autoloader provides event-driven, automatic schema evolution is present, fault tolerance is there, metadata is there, ability to handle massive file counts is also there. If your workload has always on data, the real-time logistic, machine monitoring, fraud detection, digital engagement, these are the kind of use cases in which we should use streaming ingestion pattern. But of course, streaming comes with a cost, so you must always evaluate it against your use case. These are the three things, and then the fourth one is there where we do an enterprise ingestion. So what Databricks has done is, when you integrate databases like SAS apps, CDC streams, so these are like known databases, for example Oracle, SQL, Kafka, Postgres, MySQL. So for such known databases, even for platforms like Salesforce, ServiceNow, Workday, and and such event bus. So all these things also, this platform is being provided um, something called Databricks Connect. These are the managed connectors, and these are like come under the umbrella of Lakeflow Connect, and CDC with merge into is there already as a property. Enterprise ingestion is recommended when the data source is OLTP, not file-based. You need continuous synchronization between the system of record and Lakehouse. You want zero code connectors with serverless compute. You want to change data source, change data capture applied to delta table, and you need governance, lineage, and enforced through Unity catalog. So therefore, in such cases, we should go for a managed connector. Internally, they would have a lot of facilities where they would spread a right number of threads, and they would have the stages to manage that data transfer. If there is an incremental load that we need to set up, managed connectors are the best place to do them. Once the data land into bronze, merge into is the tool of choice to maintain accurate silver tables. So we use this Databricks Connect to get the data, and then after that we can keep merge into. Handling, so this particular method is good for handling upserts, SCD type 1 and type 2 logic, deduplication, late arriving updates, everything is being inbuilt in that. Business driven state changes, all these things are inbuilt. So let us try and understand what is the decision framework. When you take the decision, how you take the decision. First is, if there is a freshness requirement that we want fresh data in particular time, then you should go for near real time. Okay, near real time, and therefore streaming autoloader is the option. If you need periodic updates, then incremental copy into is the option. If you need only initial load or snapshot, then CTS is the option. Based on the source type, if source type is files, then what we do is CTS copy into autoloader is the option. If it's database, as I mentioned, you should go for Databricks Connect or managed connector. For SaaS application, again, for SaaS application like Workday, Salesforce, managed connector is present. If you start building it, it will take months to build those things out. So you should use something which is already available. Event stream, Kafka, there is something that has recently come in Databricks. I have not explored it yet, something called Zero Bus. I have heard articles on that, but I think that is an in-house inbuilt product where we don't even have to go to any cloud provider. So internally, Databricks is taking care of that. Then based on the complexity of update, if it's append only, copy into and autoloader is the option. But if it's like very complex, then you should go for merge into and CDC. Uh, Based on governance need, definitely managed connectors already are integrated with UC. In case of simple raw ingestion, CTAS and copy into are the option, whereas in case of high traceability, metadata columns and delta logs are also being provided. So putting all these things together, we use CTS when you need an ingest an entire dataset at once, usually for the initial load or backfills, at the cost of reprocessing is acceptable. Like if at all some issue is there, then you might have to just completely reprocess the entire system, which is acceptable. If you use copy into when you have files that arrive regularly, frequently arriving files, and ingestion must be incremental, idempotent, or reliable with minimal orchestration. Like just run it regularly, monthly, daily, every hour, something like that. Okay. We use autoloader when the latency is a matter. We can use in a continuous mode. and that then again provide the additional advantage of schema evolution, especially for massive and unpredictable workloads. So we don't know when it is coming, and if it at all it comes, how to evolve our schema to accommodate that. So all those things are possible. Manage connector when you are dealing with any enterprise data system such as SaaS application or databases. Use merge into when there is a requirement that we should have upserts, deletes, deduplication, late arriving data, and for such scenarios, especially there is one word we use merge into when we have like a streaming silver and gold layer. Then we definitely go for merge into. You use upserts for that. The Databricks Lakehouse offers unified ingestion ecosystem through Lakeflow that adapts every kind of data system and business requirement. When you are ingesting historical files, streaming events, database records, and SaaS application data, each ingestion pattern has a purpose and sweet spot. You need to analyze this first: shape, volume, freshness, business criticality, rate of change, governance, and based on that, you need to take the cost factor into account and then take the final decision of ingestion. This white paper is just a blueprint to help architects, engineers, and team, those who are trying to take the decision on how to ingest the data into Lakehouse. This is just a beginning, and ingestion strategies that are not only scalable but aligned with business reality. Ingesting data correctly is more than a technical decision. It's a strategic choice that we make, and it is going to stick with you for the entire life cycle of a project. So you should take the decision very wisely. Thank you guys for listening into this. This